The RBS-15 Mk3 missile is designed to engage ships of major classes, including high-speed small ships, in the open sea, scaries, bases and near shore. The main carriers of the new missile will be missile boats, corvettes, frigates, aircraft, as well as stationary and mobile coastal defense systems. The RBS-15 Mk3 missile is a development of the RBS-15 Mk2 missile. It uses the same combat unit, guidance methods and control software. However, RBS-15 Mk3 has extended range, improved target detection capabilities and provides more effective penetration of the enemy's BMD due to reaching the target at extremely low altitudes, maneuvering by random law and increased engine thrust at the end of the trajectory. The RBS-15 Mk3 missile was developed by the Swedish company, saab Bofors Dynamics. The anti-ship complex with RBS-15 Mk3 missile is part of the armament of Swedish corvette, Visby, Polish corvette of Project 621 and prospective frigate of Project F-125 of German Navy. It was announced about the Finnish Navy's rearmament program, which provides for replacement of previous versions of RBS-15 with a new missile. The missile was tested until 2007 at the Swedish Ministry of Defence's Widsel test site. In the course of the tests, the full cycle of RBS-15 Mk3 onboard systems was tested, including the interception planning system, checking the target detection capabilities of the CNS and maneuvering the missile in the final trajectory section with high overloads. At the final stage of the RBS-15 Mk3 missile launches were carried out by an onboard missile battery. During one of the flights, the missile flew 165 kilometers through 25 route turning points and was pre-programmed to capture 2 target ships and 1 ground before hitting the final target, the ship. The RBS-15 Mk3 rocket is arranged according to the aerodynamic scheme, duck, with cross-shaped arrangement of folding arms and wings. The power pack includes a turbojet engine, microturbo TR 65 inches with an adjustable thrust vector and 2 solid fuel starting accelerators. Small-sized single-shaft turbojet engine TR 65, designed by French company Microturbo and equipped with a 3-stage axial compressor. The TR-65 develops static takeoff thrust up to 4.4 kilonewtons. In addition to aviation kerosene JP8, the engine can run on synthetic high-calorie fuel JP10. The thrust vector of the launch accelerators is inclined to the longitudinal axis of the missile at an angle of 18 degrees. The RBS-15 Mk3 has a maximum range of 200 kilometers due to its larger capacity fuel tank and higher density fuel. According to the developer company, in the future it is possible to increase the range up to 400 kilometers. In order to reduce the effective scattering area, the glider design provides for the wide use of radio-absorbent materials, as well as the control of the angle of inclination of the CNS antenna mirror. Reduced infrared visibility is expected to be achieved by shielding the engine bay, which will reduce the value of the sheath radiation factor. The missile's onboard equipment consists of an inertial control system, a new digital autopilot, an adaptive radio altimeter, a computer and a radar CNS. The missile is guided on a low-altitude march section of the trajectory by means of an inertial system with a radio altimeter, which ensures its flight to a target in a straight line or a program turning to a target at a predetermined point, as well as its flight over obstacles. The control system allows for repeated search and attack when the target's capture is broken, as well as anti-aircraft maneuvering in vertical and horizontal planes at the final point of the trajectory. It provides for the exchange of data between missile carriers and various sources of target designation, and coordination between coastal batteries, ships and aircraft. The millimeter-range monopulse radar CNS with wide antenna aperture and aperture synthesis makes it possible to reliably distinguish sea targets against the shore. A variant of equipment RBS-15 Mk3 of combined radar and passive infrared homing head has been developed. The use of the combined radar and passive infrared homing head dramatically increases its interference immunity and the probability of hitting the target in the conditions of strong radio-electronic counteraction. In addition, a terrain guidance system is being developed for the missile, and a Navstar space radio navigation system receiver is being considered. The missile is equipped with a 200 kg shrapnel flash BC, which can be detonated both when hitting the target directly and from non-contact sensors. Missile Engagement Planning System Automatic Firing Control System has a graphical user interface and allows to process data from various sources of target designation, develop a plan of fire, control pre-launch preparation and launch of missiles.